Hello and welcome. Today we're doing a question from LeetCode 75. It's called minimum flips to make A or B equal to C. So what is this question? Given three positive numbers A, B, and C, return the minimum flips required in some bits of A and B to make A or B equal to C. This is the bitwise OR operation. And flip operation consists of changing any single bit 1 to 0 or changing the bit 0 to 1 in the binary representation. Example 1, we have A being 2, B being 6, and C being 5. So A in binary is going to be 0, 0, 1, 0. B is going to be 0, 1, 1, 0. That's just 4 plus 2 to make 6. So what is A or B? A ORed with B is just going to be every single bit ORed together. So 0 ORed with 0 is going to be 0. 1 ORed with 1 is 1. 0 ORed with 1 is also 1, because remember, with an OR, either A or B needs to be 1 to get a 1. It could be A, it could be B, it could be both. It's going to be a 1. And the only time we're actually going to see a 0 in an OR is if both A and B are zeros. So this is A or B. Now what's C? C is 5, so in binary that's going to be 0, 1, 0, 1. We want to flip some bits in A and B so that A or B equals C. So again, just going bit by bit, we see that the first bit over here, the least significant bit, is 1 for C, but it's 0 for A or B. So we know we need to flip one bit, either A or B, to get a 1. And we want to do the minimum flips required, so we don't actually need to flip both. Flipping 1 is going to be enough. Say we flip A over here to become 1, then A or B is going to be 1 for this bit. This means we've made one flip so far, and now C equals A or B. Moving down, C is 0, and A or B is 1. Now, A or B is going to be 1 for one of three reasons. Either A is 1, B is 1, or A and B both are 1. We need to see which ones we need to flip to 0 to make A or B equal to 0. We see A is a 1, so of course we need to make a flip over here, so we've made 2 flips so far. But A or B is still going to be 1 because the B's still 1. So we also need to flip B's bit over here, meaning we've made 3 flips so far. Now that both of these are 0, we can have A or B being 0 over here. And moving on to the next bit, C equals A or B. And these are just 0, so they're going to stay as is. So in total, we needed 3 flips to make A or B equal to C. Example 2, we have 4, 2, and 7. So how would that play out for this? So with example 2, we have A being 4, B being 2, and C being 7. Again, checking what A or B is going to be. The first one is going to be 0. And we want a 1. So we know we need to make one flip. Either A or B, doesn't matter. So we're going to have one flip here. A or B here is 1. And C is also 1, so nothing to change here. Then A or B over here is also 1. And C is also 1, so we're good over here as well, which means we needed one flip in total. And last example, we have 1, 2, and 3. So example 3, we have 1, we have 2, and we have 3. Now C here is 1. A ORed with B is going to be 1. The second digit, C is 1. A ORed with B is also going to be 1. So no flips are required, and we output 0. So how are we going to solve this? This is going to be exactly what we've just done right now. We're going to have flips initialized to 0, and we want to go through all the bits of A, B, and C while they're all greater than 0. So while A greater than 0, or B greater than 0, or C greater than 0, we want to get the least significant bit for A, B, and C. And the way to do that is just to AND it with 1. So A bit is going to be A ANDed with 1. B bit is going to be B ANDed with 1, and C bit is going to be C ANDed with 1. Now, what does AND 1 do? Say we have example 1 again over here. So we have A being 2, B being 6, and C being 5. A ANDed with 1 essentially clears out all these other bits except for the least significant bit. And that's because ANDing with 1 is an identity operation. If A is a 0, 0 ANDed with 1 is going to be 0. But if A is a 1, 1 ANDed with 1 is going to give us a 1. So we're going to get whatever we had in that last place. And if we wanted something in the last 2 places, we would simply AND it with 1 and 1 to get whatever we have in the last 2 bits. We're only interested in going bit by bit, which is why we're ANDing everything with 1. So right now, A bit is going to be 0, B bit is going to be 0, and C bit is going to be 1. Now we just want to check what C bit is. So if C bit equals 1, then we need A or B to also equal 1. If that's not the case, we know we need to make one flip either to A or B. So if A ORed with B is not equal to 1, we know flips is going to be plus equals 1. We need to flip A or B. And in this example, we see that that is the case. C bit is 1, but A ORed with B is not 1. So we're going to have one flip. So flips is going to equal 1, and intuitively all that means is we flipped one bit for A or B, so the A or B is now going to be 1. If that's not the case, so else we have C bit equaling 0. If that's the case, then we need to see if both a bit and b bit are 0. If they're not, we need to flip both of them into 0. So if a bit equals 1, we're going to do flips plus equals 1, and same with b. If b bit equals 1, flips plus equals 1. They both need to turn into zeros. Once we're done with all of this, we just need to move on to our next digit. We're getting the least significant bit. So all we need to do is do a right shift on A, B, and C. So A is going to be right shifted by 1, B is going to be right shifted by 1, and C is going to be right shifted by 1. All that means is A is going to move to the right, so we get rid of this bit that we were just on, and same for B, and same for C. And we keep going in this while loop up until we still have bits to process. Once that's done, all we need to do is return flips. So let's go ahead and submit this. Wrong answer. Let's see what's happening. A bit, B bit, C bit. Oh, this should have been A bit and B bit. We only want to see if that bit is equal to 1 or not. Now let's go ahead and submit this. And it is accepted. Now before leaving, let's complete our entire example walkthrough just to see how our code is going to run line by line. So we had left with right shifting everything in the end. We had 1 flip in total in our first iteration. So going back in this while loop, all of these are greater than 0. So we can go in there and we want to get the least significant bit for A, B, and C. So A is going to be 1, B is going to be 1, and C is going to be 0. So we don't go in this if because C bit is not 1. We're in this else. And we want to check if A bit equals 1. That it does. So we need to add 1 flip to convert from 1 to 0. So right now we have 2 flips and all we're doing is flipping this to be 0. And we also check for B bit. B bit is also 0, so we need to go ahead and flip that, which means we've made 3 flips right now. So now A or B does equal C. Once this is done, we just right shift again. So A is going to move down, B is going to move down, and C is also going to move down. Going back in this while loop, this is still true. We find the bits again. A is 0, B is 1, C is 1. If C bit is 1, that's true. If A bit or B bit is not equal to 1, that's not true, right? Oring A and B is also 1, so we don't do anything. We don't add to the flips. We just right shift. So right now, everything has gone to 0, which means we don't go in this while loop, and we just return flips, which is 3 and exactly what we were expecting, right? We need 3 flips to make A or B equal to C. So we just went ahead and solved minimum flips to make A or B equal to C. If you have any questions with this whatsoever, of course, let me know down below. I'll answer all of them. If this video was helpful, like, comment, share, and subscribe. It really supports the channel. And as always, I will see you in the next one.